Good morning, everybody. Today's class is about thalamus. Like basal ganglia, thalamus is also a large subcortical mass of gray matter situated obliquely, one on either side of the third ventricle. That means it occupies both halves of the brain. It has an isthmus or an intermediate mass which is a bridge of gray matter that crosses the third ventricle to join the right and left halves of the thalamus. Thalamus, subthalamus, epithalamus, and hypothalamus together constitute diencephalon. It measures around 3 mm in length and makes up around 80% of the diencephalon. The anterior end of thalamus is narrow, whereas the posterior end is expanded and forms the pulvinar. The reticular nuclei of thalamus separated from the internal capsule. So thalamus consists of a gray matter. There is external and internal medullary lamina which contains white matter. The external medullary lamina is situated on the lateral aspect of thalamus consisting of thalamocortical and corticothalamic fibers. And the internal medullary lamina is Y-shaped sheet of white matter seen inside the thalamus. It consists of nerve fibers that pass from one thalamic nuclei to another. Interconnected nuclei are present. The internal medullary lamina divides thalamus into anterior, medial, and lateral group. The cerebral cortex operates in close association with thalamus, so that both are considered anatomically and functional as a unit, referred to as thalamocortical system. This is an introduction. Generally, these subcortical structures, particularly thalamus, basal ganglia, cerebellum, assist the cerebral cortex in producing the intended movement in the most effective manner. In Greek, thalamus means inner room, so it constitutes a major part of diencephalon. So where is it located? It is located, you should know the scheme of lecture. Where is it located? Relations of thalamus, classification of the nuclei, connections and functions and applied aspect. It is part of diencephalon. So thalamus and geniculate bodies along with hypothalamus, subthalamus, epithalamus and the third ventricle lies between the two halves of the diencephalon. So it is located anteriorly towards the internal capsule. In front of the thalamus, you can see on both the sides, this is the third ventricle. The two halves of the gray matter, which are subcortical, and it's an intermediate mass. And behind, posteriorly, we have substantia nigra, part of basal ganglia. The divisions are mainly the ventral group, the dorsal thalamus, and the epithalamus. Epithalamus, which is the pineal body which inhibits the gonadal cortex, which is controlling the sexual function, and it also secretes melatonin. It has a posterior commission. As you all know, the ventral thalamus is concerned with the reticular complex of thalamus. It surrounds the dorsal thalamus on the lateral and anterior side. It is part of the ascending reticular activating system. It receives fibers from intralaminar and midline nucleus of thalamus and projects to all parts of the cortex. So this is a general overview of thalamus, and we have different dorsal thalamus, the anterior group, the midline group, the medial, the lateral group, and posterior group. So if you generally take the three parts, the anterior, medial, and the posterior, how they are classified with the Y-shaped internal medullary lamina, which is a fiber which I have told you in the introduction. It's a sheet of white matter. How it divides the median and So we have different nuclei. The lateral nuclei, the medial nuclei and the anterior nuclei. You can see the different nuclei. How they are forming the anterior nucleus, the midline and the intralaminar nuclei. So the dorsal part is mainly by the medial dorsal nucleus, the lateral dorsal nucleus and the lateral posterior nucleus. As you all know, most of the ascending tracts except for the smell was relayed in the thalamus before it got projected into the cerebral cortex. You all must have come across ventroposterolateral nucleus, which is present just posteriorly in the front of the pulvinar. And we have the lateral geniculate body, which is concerned with vision, and the medial geniculate body, which is concerned with audition. So this is the general nuclei of dorsal thalamus. So the different dorsal part when you posteriorly see. So there are different nuclei per se. If you take the ventral group, we have ventral anterior nucleus, ventral lateral nucleus, ventral posterolateral nucleus and ventral posteromedial. And the posteriorly we can see we have the pulvinar, lateral geniculate body and medial geniculate body. So these are the parts of the dorsal thalamus, where the anterior group we have the midline and the internal and medullary lamina, how it divides into dorsal medials, and the posterior most broad we have the pulvinar, the ventroposterolateral nucleus, and all these the lateral and medial nucleus. There are different connections of the dorsal thalamus or generally thalamus. The thalamus per se is a collection of nuclei which is separated by the internal medullary lamina and external medullary lamina, situated, as I described, it's a Y-shaped lamina. And these have afferents and efferents. For example, the medial lemniscus, which is a spinothalamic tract, is a continuation of fasciculus gracilis and cuneatus. It conveys fine touch, pressure, vibration, proprioceptive sensation to the ventroposterolateral nucleus. The spinal lemniscus, it carries pain, temperature, crude touch senses to the ventroposterolateral nucleus. The trigeminal lemniscus, it carries all sensation from trigeminal area to the ventral posteromedial group. The sensory visceral fibers from hypothalamus, they terminate on the medial part of thalamus. So these are the afferents, along with the cerebellar afferents from the opposite side. They terminate to the ventrolateral nucleus. The rubrothalamic tract, where the fibers from the red nucleus of the same side terminate on the ventrolateral nucleus. The corticothalamus fibers from different part of the areas of the cortex, they terminate in different nuclei of thalamus. So it has different connections. The afferents are medial lemniscus, spinal lemniscus, trigeminal lemniscus, sensory visceral fibers of hypothalamus, cerebellar, then corticothalamic fibers. So it also has connections with globus of basal ganglia, emotions, so it's concerned with the amygdaloid, then mammillothalamic tract forming the Papez circuit, which is concerned with limbic cortex and plays a role in emotions. So optic tract conveys in the lateral geniculate body. So all these are concerned. So we may have specific sensory nucleus. If you functionally classify them, we have specific sensory nuclei like medial geniculate body, lateral geniculate body, the ventroposteral and postroventral nucleus, the medial and lateral part, the ventral lateralis and ventral anterior and anterior. Whereas the non-specific projection nuclei are midline, intralaminar and reticular nuclei. There are different connections which is very essential for us. Whereas the efferent connections of thalamus are the thalamocortical fibers. They are widely distributed in different parts of the cerebral cortex. The efferent fibers to caudate nucleus, the efferent fibers to globus pallidus, efferent intrathalamic connections, efferents to hypothalamus and midbrain. So we have afferents and efferents. There are different ways of studying thalamus which can be either stimulated or either sectioned with ablation or causing semi-decortications and by various lesions. When you stimulate, there will be hyperesthesia or paresthesia on opposite side, but to some extent on the same side. There is increase in electric activity of the whole cortex and some motor effects, and it can induce sleep. When you ablate it or you section it, loss of sensation in the opposite side of the body, there is semi-decortication, the initial loss of sensation in the opposite side of the body and return of crude sensations. So what are the general functions of thalamus? Most of the crude sensations are perceived in the thalamus. Only the final discrimination of any sensation can be in the cortex. It's a sensory relay station and gateway for all types of sensation to the cortex except olfaction. The thalamus is an important subcortical relay center for most of the sensory pathways. Modification of impulses occurs in the thalamus. It plays an important role in appreciation of protopathic sensation like pain, crude touch, crude temperature. Although crude perception of these sensations occurs at the level of thalamus, precise localization of these sensations depend on nerve impulses reaching the primary sensory area of cortex. So we have vision in the lateral geniculate body, different taste, hearing and the medial and deep sensations. So pain is perceived in the medial nuclei. Visceral sensation, sexual sensation, it has association with subjective emotional feeling, that is, it has a connections with what is called as mammillothalamic tract forming the Papez circuit, which is concerned with limbic cortex, mainly the emotions. It also plays a role in arousal mechanism. The non-specific projection nuclei of thalamus form important part of ascending reticular activating system. This system is responsible for regulation and maintenance of consciousness, alertness and attention of the individual. Almost all sensations can activate ascending reticular activating system. The level of activity in ARAS determines the alertness of the individual. So the reticular part of the thalamus forms the part of ARS and helps in maintenance of arousal and alertness. It also forms a part of the genesis and synchronization of electroencephalogram. How? The thalamocortical thalamic reverberating circuits may be responsible for genesis and synchronized EEG rhythm. It also has different connections with the deep nuclei of cerebellum, that is the dentate nucleus, and corpus striatum of basal ganglia, and thereby the intended movement is performed in the most effective manner. So we need to understand that thalamus contains different groups of nuclei. They have to and fro connections to the specific area of cortex. Majority of the sensory inputs go. The information received by thalamus is segregated and analyzed, and related information processed by thalamus is converted to primary and association area of cerebral cortex. So impulses from basal ganglia and cerebellum influencing the motor activity of cerebral cortex pass through thalamus. So it's an integrating center. As I told you, there is medial nucleus of thalamus and hypothalamus. Prefrontal cortex are concerned with emotional exteriorization. So we need to understand that there is modulation by the, and it forms a part of the integrated nervous system observing personality, emotional affect and social behavior. So it's concerned with emotional and social behavior, mainly by the Pepper circuit. So once again, thalamus is nothing but it is each of the brain contains a thalamus, which is a large ovoid grey mass of nuclei. So all the subcortical structures are grey matter. These structures are important for regulation of basic functions and linkage of basic functions to more complex functions such as movement. Thus, it's a grey mass of nuclei. Once again, to revise, the thalamus is thought to be a crucial structure for perception of some types of sensation, especially pain, and the sensory cortex may give finer detail to sensation. If you generally know the functional nuclear groups, the sensory nuclear is involved in relaying and modifying sensory signals from body, face, retina, cochlea, and taste receptors. The motor nuclei convey motor information from cerebellum and to the precentral motor cortex. The limbic nuclei convey information from hypothalamus and cerebral cortex. The multimodal nuclei have connections with the association area of parietal lobe. The intralamina, which are non-specific connection, are not understood well. The interaction with, which has a to and fro connections to the cortical motor area, the caudate and the putamen, and the cerebellum has been demonstrated. So this is the functional relationship of the nuclei with the sensory, motor and emotion and the so coming to the epithalamus, which is part of the diencephalon, which consists of pineal gland and Heban nucleus. It's a cone-shaped endocrine structure which inhibits the influence of gonadal function. It has diurnal rhythm. This Heban nucleus serves autonomic functions and emotional drives. As you all know, the geniculate bodies have relay center for vision. The medial geniculate have also the relay center for audition. Thalamus has lateral geniculate nuclei and medial lateral geniculate nuclei is concerned with vision. The medial geniculate nuclei is concerned with audition. The ventroposterior nuclei is concerned with somatosensory and the Mars intermedia crosses midline. The reticular nuclei, which is located between external medullary lamina and internal capsule, receives and projects within the thalamus. It integrates and regulates thalamic nuclei. The anterior nucleus is related to limbic brain and contributes to the direction of digestive, respiratory, urogenital and endocrine function, whereas the posterior group channels sensory information, pain, temperature and taste, audition and vision. It integrates sensory motor information and also receives information to and from basal ganglia, cerebral cortex and thereby causing an effective intended movement. It regulates functions of association in cortex and cortically mediated speech, language, and cognitive function. So, thalamus has a role in language development also. So, the cognitive functions of thalamus are it is involved in language and speech functions. Types of subcortical aphasia include thalamic based aphasia, where the left dominant thalamus is involved. Here, there is a fluency problem. Neurogenic stuttering from surgeries in thalamus. Thalamic syndrome. Gross detection of sensation at thalamic level. Thalamic pathology can result in very strong misinterpretation of sensations. So generally, thalamus is an integrator and gateway for information. The subthalamus is important in motor control. The hypothalamus mediates endocrine and metabolic states, whereas epithalamus, which is diurnal and automatic body functions, the diurnal functions refer to regulation of sleep, wakefulness, body temperature, and metabolic rate. So this is a general function of the diencephalon. The thalamus is nothing but also called as inner room, which is located between the third ventricle, occupies both sides of the brain, which has different types of nuclei. That is mainly the dorsal, ventral, and the posterior group, and each has afferent and efferent connections. The afferent are the medial lemniscus, spinal lemniscus, sensory fibers from hypothalamus, fibers from cerebellum, rubrothalamic, corticothalamic from the cortex, whereas the efferent connections are from the thalamus to cortex, towards the caudate nucleus, to the globus pallidus, to the intrathalamic connections, and hypothalamus and midbrain. So it's a main sensory relay station. It's a subcortical center for perception of pain. It helps in information storage and short-term memory. It is functional part of the reticular activating system responsible for consciousness, sleep, and wakefulness. It forms a part of the neural circuit, that is, Pepe circuit for emotional experience, personality, and social behavior. It regulates autonomic functions associated with emotion. It forms a part of the posture adjusting system, helps in motor cortex to modify and update signals. It integrates cortical and subcortical areas for execution of speech. It's an important role in genesis and synchronization of waves of EEG. It forms a link between cerebellum, basal ganglia, and cerebral cortex. In short, thalamus plays a key role in mediating sensation, motor activities, cortical arousal, learning and memory, acting as a gateway for cerebral cortex. So what are the lesions of thalamus? See, any neoplasm or disease affecting blood supply to the thalamus leads to degeneration of thalamic nuclei, especially posteroventral nucleus. The thalamo-geniculate branch of posterior cerebral artery is usually blocked due to thrombosis. Bleeding or hemorrhage following very high blood pressure is another cause. Depending on the degree and site of block, other areas are also affected. Collectively, manifestations are called as thalamic syndrome, wherein it's a vascular lesion involving the thalamo-geniculate branch of posterior cerebral artery. Here we have different. This was described by Degerine and Rouse. The features are impairment of position, that is, the person is unable to localize the position of the limb. So this is thalamic phantom limb or amylognosia. There can be passive movement, light tension localization, temperature on opposite side, hemianesthesia, loss of sensation in the opposite half of the body. There can be what is called as thalamic overreaction, where paroxysm of spontaneous excruciating pain in the opposite side of the body are present. This is called thalamic overreaction. The pain is aroused by light touch or cold and does not respond to powerful analgesic drugs. Sensation of the affected side may be associated with emotions. There is sensory ataxia where there is loss of kinesthetic sensation. Movements are uncoordinated and clumsy. Involuntary movements like choreoathetosis and tremor. Amylognosia is that he feels there is no limb and he also searches for the limb because the person is unable to localize the position of the limb. This is called as thalamic phantom limb. If lateral geniculate body and medial geniculate body is involved, vision and hearing will be affected. A particular position of the hand called thalamic hand is observed. This is due to flexion at wrist and metacarpophalangeal joints and extension of interphalangeal joints due to alteration in muscle tone. There can be emotional disturbances. Hemiparesis and defects in visual field are seen if internal capsule is also affected. So thalamus is a grey mass of nucleus. It is also called inner room. It is around 3 mm in dimension, occupies 80% of the diencephalon, which is different collection of nuclei separated by the two laminae, the internal medullary and the external medullary laminae. And these are the different groups of nuclei which subserve different functions ranging from sensation, motor activity, sleep regulation, emotion, genesis of EEG, and most of the crude sensation of pain is perceived at the thalamus. It's a major sensory relaxation. So we need to understand that there are specific nuclei, projection nuclei and non-specific nuclei, and a very important role in alertness and language development. So it's an integrating center for motor activity. So when there is a lesion, it results in thalamic syndrome, which is a vascular anomaly.